we have a professional Python programmer and enthusiast. Let's give a big round of applause for James.
This is How Many Oranges? We are at PyCon India. It's Sunday, September 22nd, 2024. My name is James Powell. If you'd like, you can try to connect with me on LinkedIn or not. I don't really care one way or the other. I accept all connection requests. Honestly, I'm really beginning to hate LinkedIn. But having said all of that, let's get started. But before we get started, I really need to share with you a couple of very important disclaimers for this presentation. The first disclaimer is, the organizers have told me that we're already past the point where you're able to get a refund on your ticket, so if you don't like this talk, tough luck. The next, most critical disclaimer is, there are certain parts of this talk that are very passionate in my mind, and I have tried my hardest to remove the swear words. If I slip up, I beg your apologies. The next disclaimer is, for those of you who may have had the misfortune of seeing a previous presentation of mine, there is a little bit of repeated material in here. There's not solely new examples. And then finally, and most importantly, we're going to start with a story, and it's a story about somebody in my life. It's a story about somebody I love with all of my heart, who deserves respect, perhaps more than I might show them in this particular story. So let me tell you a story of something that happened years ago that still stays with me to today. I have a relative whom I deeply love, who was visiting me, went to the grocery store, bought me some groceries. Among those groceries was a bottle of fresh squeezed orange juice. And like many of you, I had had orange juice all my life, but I'd always had the pasteurized type that's just like sugar water. And I thought to myself, I don't really like orange juice. But when I tried the fresh squeezed orange juice, my goodness, it was amazing. It was some of the best I've ever had in my life. And I was so happy with this one glass of orange juice that I turned to my relative and I asked, how many oranges does it take to make a glass of orange juice? And their response stays with me to today. Without any hesitation, they turned to me and they said, well, it depends on the size of the oranges. And I was speechless. It took me a moment to really compose myself, because that is the stupidest thing I've ever heard anybody say in their entire life. What kind of idiot are you to tell me it depends on the size of the oranges? Of course it depends on the size of the oranges. If the oranges are very big, it will take fewer oranges to make a glass of orange juice. And if the oranges are very small, it's going to take a lot of them. I think I can figure that out. What is wrong with you that you would think that that is an intelligent, appropriate answer for the question that I just asked you? And the passion that I felt in basically tearing them apart really led me to ask myself, well, why are we here? What's going wrong? Clearly, we are answering the wrong question. The person who told me it depends on the size of the oranges perhaps should have thought, well, why are you asking this in the first place? What is it that you don't know that you actually would verbalize this question? They would say, maybe I should tell you something useful. Maybe I should tell you something that you don't already know. Maybe I should even take a little bit of thought to think about what I'm going to say, to anticipate, to put myself in your shoes and try and figure out what can I tell you that is not wholly and completely obvious. And yet, it goes beyond just this one story, because in truth, this frustration is something that I felt outside of the circumstances of interacting with this absolutely lovable, but somewhat difficult to be around relative. Because how many technical conversations have I had with people that devolve into exactly the same thing? I asked them a question, should I use this feature? Is this the right way to model this? And they answer, it depends. Or they say, it depends on what you're trying to do. Of course it depends. What doesn't depend on what I'm trying to do? What did you tell me that I don't already know? Or one of my other least favorites is they tell me it's a series of trade-offs. What isn't? Tell me, what are the trade-offs? Now, setting that aside, calming myself down for just a moment, I will admit to you, I get it. If you're saying it depends, or if you're saying it's a series of trade-offs, because what you really mean is go away, okay, fine. But honestly, you can just tell me, go away. You don't need to give me these terrible answers. And unfortunately, I really think that it's not the case that you're telling me to just go away with these very poor answers to my questions. I think it is unfortunately indicative of the sad state of our field. Specifically, that in the field of software programming, I will not call it software engineering because it is not an engineering discipline. There is a lack of foundational knowledge. There is a lack of a theoretical framework. And many of us come from quantitative backgrounds, and when we think of theoretical framework, we think about this in the context of something like physics. But if you think about programming as an activity, which is wholly dominated by human considerations, business problems, well, the theoretical framework that we would adopt might not look like a computer science framework, a mathematicalized framework, but instead much closer to a framework like those you find in economics, a balance of a mathematicalized framework with one that is based on qualitative reasoning. In fact, this has been, in recent years, the focus of my work. Where I do instructional or educational work, I try to focus on how can we develop such a theoretical framework to be able to answer these questions more reliably than with these pat answers. Part of it is what I might call theory origination. Where can we find the missing computer science theory? The theory that does not look like algorithms and data structures and dynamic programming, but instead looks like guidelines and reasoning for why it is and how it should be the way that we do things. The goal here is to take these mindless, meaningless answers and to turn them into something meaningful and useful. And so I'd like to give you an example. And in this example, I want you to ignore some of the specific details of the example. I would be more than happy to litigate with you whether my reasoning is correct or not. In fact, any theoretical framework needs to stand up to such scrutiny. But instead, what I'd like for you to try to do is to see the way in which this has been implicitly constructed, to see the thought process that allows us to create such a framework and what this can allow us to do better than just answering, it depends. And so I'll start with a very simple question, one that comes up fairly often when you introduce people to Python. After all, we're all Python programmers at different levels of experience, and in using Python, we encounter things like positional and keyword arguments. And somebody will ask you, when do I use positional arguments and when do I use keyword arguments? And for those of you who need just a very brief refresher, remember, in Python, we have functions. And we can call those functions in many different styles. We can pass x and y positionally, as you see in this example. We can pass them by keyword, as you see in this example. Or we can pass x positionally, and we can pass y by keyword. With PEP 3102, we can even enforce that x and y must both be passed by keyword. Thus, if you try to pass x positionally, it's an error. With PEP 570, we can even enforce that x must be passed by position only, thus making this an error. And for many of us, when we look at the choices outside of what PEP 3120 and PEP 570 indicate to us, we might assume this is purely aesthetics. But even questions like this, when you dig at them just a little bit, reveal that there is an underlying controlling theory. Let me share with you a couple of details of that theory as an example for how to build a theoretical framework of this form in order to answer these questions much more usefully. If we have a function that takes arguments x and y, it is very often the case that we can look at the boundaries of how these functions might be defined. We can look at, for example, that it's very commonly the case at the extremes that some of the arguments that we pass in are data arguments, and other arguments that we pass in are modal or mode arguments. When we say data arguments, we often mean for something that performs a computation, what are we performing that computation on? And for modal arguments, we mean qualifications on how we are performing that operation. Oftentimes, we might use the word mode interchangeably with modality, law, option, or flag. And so, as a concrete example for the pandas users out there, we have pandas.readcsv. You can think that in the arguments that you can pass to pandas.readCSV, you can pass the thing that it's going to operate on, the data, the file path or buffer, and modalities related to how you're going to operate on this. For example, the separator you're going to assume. Is it comma separated? Is it pipe separated? And in fact, if we look at the actual read.csv, we can see that there are an enormous number of modalities, in part because CSV is a semi-standardized format, and so there's all sorts of different considerations that come up. When we think about that, and we think about how this plays out in actual code, we might say if somebody wrote some code that looks like this, it is nearly unreadable. What does this actually do? Clearly it operates on data.csv, but I have no idea what these remaining arguments are. These modalities are very unclear. And with a very small change to this code, for example, indicating that I mean to separate the data with semicolons, that there is no header line, that the names of the columns are, as you see, that I'm going to use these two values or these two columns as my index, that I'm going to parse dates in such and such column, this code now becomes readable. Except for most of you, that index equals doesn't make any sense because for whatever reason, nobody seems to use the index on a pandas data frame or a pandas series, despite it being probably the only interesting part of pandas. But setting that aside, what's interesting is, if we denote the first argument, the file name, this does not aid in the readability. You don't need to tell me that the file name is data.csv. I could figure that out. You need to tell me what the modalities meant, however. And thus, we can originate from this some practical operationalizable guidance. Typically, the data arguments are usually obvious. They're obvious from the name of the thing. They're obvious from, if you're using this, you kind of know what you're using it on. And the modal arguments may be obvious only in a certain context of use. And especially in the case of there being many disparate contexts of use, it may not be obvious to an end user. Well, hold on a second. I don't know what that flag does because I never encounter CSVs that look like that. They need to be indicated. Therefore, if we have data and modal arguments on our function, it makes sense for the data arguments to be passed perhaps optionally by keyword, and they can be passed by keyword as an aesthetics measure in order to improve the readability in perhaps very complex or dense code. But it also makes sense to enforce that the modal parameters be passed by keyword only in order to ensure the readability in the case where not all users of this function are aware of the available modalities. Now, when we look at this theory, one of the things that we want to identify is whether the theory that we're originating is durable, whether this theory actually makes sense, whether it can be litigated, because there's a lot of qualifications here that I don't think I can prove in a rigorous manner. And one way we can do that is by extending this theory beyond, for example, functions. We can look at generators. If we had a generator, well, this seems to also make sense and line up a lot with how we might use or write generators. If we had an asynchronous task, which you might call a capital C collections.abc.coroutine, similarly, we might also use this methodology. If we had a lowercase c generator coroutine, we might do this, but the whole point of a generator coroutine is that we have the ability to take a computation and break it down into parts and pass in partial inputs. So it seems like we have the ability to pass data in two places, and that is a little bit odd. And if we think about it a little bit more, we might say, well, in the first data argument, that's, I guess, the initial data, but now we're beginning to surface something that's a bit uncomfortable, something that's standing out from the clean theory. We're seeing that there's an implicit or inherent modality here. But we already know there's an implicit or inherent modality on generators and generator coroutines because, as we all know, I don't even have to look at the screen for this next thing. You can't send a non-none value to a just started generator. I'll let you guess how I know the exact wording of this error message such that I can recite it from memory. Well, coroutines, generator coroutines, have an inherent modality. And that inherent modality is what we might call a first rest modality. What you can do in the first step is meaningfully distinct from what you can do in the other steps. In the first step, you cannot send a non-none value. In all the remaining steps, you can. And this ends up being compositionally problematic for generator coroutines. Because if you happen to have two generator coroutines and you compose them together, well, what you end up with is a first rest modality here. Well, how do we know what that next first is? We don't know where it's going to be in the structure without knowing the exact length of these, and so this is completely and utterly untractable. It turns out that generator coroutines also have a much more minor rest-last modality because, for example, if we think about a generator coroutine as a computation that's been broken down into parts that can take partial input and return partial output, well, we actually can return output in two ways, by either yielding it or by returning it, and then capturing it as the E dot value on the exception. And here we can see these two modalities in play. There's some modality of something special about the input and something special about the output. But in practice, it turns out that that input modality, that first rest modality, is the dominating one. Because in truth, we can reformulate our compositional tools. We can rewrite the iter-tools module fairly easily in order to write a version of chain that eliminates the consequences of this last modality. And what we can do is we can take our first rest modality and transform it into a rest last modality. We can take the distinction of the first thing as opposed to the rest thing and say, okay, no, everything up to the last thing is the same and the last thing is different. And because many generator coroutines are infinite, we'll never visit that last modality. And so we've actually now implicitly we've resolved this. We've eliminated the modality entirely. We've made this thing much more uniform, compositionally useful, and easier to use. This is basically what we've been calling for years pumping or priming. The idea that when you have a generator coroutine, in order to avoid that can't send a non-none value to a just started generator error, you first do a superfluous next with maybe a dummy yield in order to move past that, and then you end up with a structure which takes its modalities only in the construction of this generator coroutine and only takes partial inputs through the yield mechanism, through the send mechanism. One thing to note before we look at what are the consequences of this is it's been an outstanding question whether pumping or priming is a real thing or not. Is it something that we just made up in order to use these tools, or is it more foundational, fundamental? Is it something that was planned? I don't think it was planned, but you can see some very interesting traces that clearly it evolved in this particular direction, because if we take a generator coroutine using PEP 380 delegation to a sub-generator and we disassemble it and look at the bytecodes, in the bytecodes we'll see something really weird, a load const with a send none, yield from implicitly pumps or primes the thing. This is a real thing that exists. It's just that nobody seems to talk about it, and nobody lifts it up to the level of saying, oh, if you're going to use these as the dominating feature, the dominating metaphor for your API, you need to be aware of this. Well, setting that aside, it's often commonly the case that when we work with generator coroutines, we might do what we might call API normalization. Let's make everything look the same so that we can unburden our users from having to know about generator coroutines if they choose not to allow them to make everything look like a function. And what we do is, in addition to pumping or priming, we wrap that .send method with a lambda, and we return that lambda such that you can create an instance of this primed API normalized generator coroutine and call it just as though it were a function or just as though it were an instance of an arbitrary class that you've written, which makes this a very interesting, or takes us into a very interesting dovetailing point, because in this formulation, if you're to write this as a class, don't classes always look like this? You pass in the modal arguments in the instantiation of it, and you pass in the data arguments whenever you call this thing. And you can see we've gone full circle here. There may be some validity to the theoretical framework we've originated here, in part because we are beginning to extend it past the bounds of the question we're trying to answer, and we're seeing that we are nicely answering or justifying other parts of the universe in which it exists. How about that? It all fits together. And in fact, there may be a unifying theoretical framework that answers all of these questions directly. And as we dig at this framework, we'll discover that there's more to it. And it's just lying there right in front of us for us to articulate, for us to explicate, in order to give us real, meaningful operational guidance, even down to very simple things that we do in our code. Let's dig deeper. If we have a function, and that function has modal arguments, we may often observe that there are some differences in those modal arguments. Here we have two modal arguments, a flag and an option. And there's a very clear difference in the acceptable parameters that can be passed to both of them. Flag is probably going to be true or false, whereas that option appears to be some floating point value, so presumably it can be any floating point value, maybe any non-negative floating point value, or any non-zero floating point value. Think of this as something like a timeout field. And here we can see that there are even distinctions between bounded modalities and unbounded modalities, where bounded modalities are bounded to a specific set of predefined values, true or false, and unbounded modalities are modalities that, you can pass in pretty much anything. And we can see a close relationship to something else that pops up all over the place when we look deeper into Python, the idea of distinctions between structural modalities and data modalities, or between structure and data. Now, I won't go into the distinctions between structure and data because it's a very interesting spectrum on which we have two very clear endpoints that oftentimes blend together in the middle and lead us towards some very interesting consequences. Like, there are actually two dictionaries in Python. There's structural dictionaries, which are heterogeneous on the values, and there are data dictionaries that are homogeneous on the values. And some people use dictionaries in one form, and some people use them in the other form, and they evolve and interact in our code in very different ways. I talked about this at PyData Amsterdam, I think 2 days ago. I'll encourage you to take a look at that talk if you're interested. But going back to what we said, if we have a bounded modality, one thing that we'll anticipate seeing in the code for this is some sort of if-else to determine if the flag is set, do this, if the flag is not set, do that. And if we have an unbounded modality, it's very unlikely that we'll say, if the option is 0.0, do this, if it's 0.25, do that, if it's 0.5, do this, because it's unbounded. There would be no way for us to structurally enumerate all of these possibilities, which means if we happen to have a bounded modality, and we have different ways in order to interact with this, by passing in true, by passing in false, by passing in true or false as defined through some variable, we can turn this into two entities by splitting it on the boundaries of those modalities. We can say, oh, here's f that has that mode, and here's f that has that does not have this mode, and we have no loss of generality here at all. Here we can see a transformation that is strictly always correct, where if we're in a code review and we're arguing between the two of these, it doesn't matter. They're really the same thing. They're just two formulations. This leads us to some other very common accessible theory, the idea of nominal decompositions of bounded modalities, which is itself a longer topic to get into, but it's something that we all see because if, for example, we have a class in Python, and that class can be constructed by reading from some file, which is generally a bad idea for us to do in an init, because an init should mostly be just dumb boilerplate. But assume that we have that, we can easily imagine this might grow, that the file might be a CSV file, an XML file, or a JSON file. Clearly, there's a bounded modality in play. And clearly, we are better off removing the I.O. from the init, because that makes things like pickling or unit testing much more problematic. Moving these into separate methods, specific to each one of these modalities. 80% of class methods in the wild are just this pattern of the nominal decomposition of a bounded modality. They're almost always factory functions for constructing this data and identifying bounded modalities associated with that construction. We can see that the theory ends up being quite broad in application. In fact, if we go back to where we started, we can even see that these small theoretical items, as we scratch at them, as we dig at them, are very revelatory. They give us a lot of insight into things that we might already be intuitively doing, but where we can provide meaningful guidance to others in code reviews or in terms of answering why our things are the way they are. And so let's go back. If we happen to have some function that splits its data and its mode parameters using PEP 3120 keyword-only arguments, a question might arise, when does PEP 570 or PEP 520 positional-only arguments come up? And this is actually a much harder question to answer because this is somewhat obscure. But we can dig a little bit to think about this, and I'll fast forward you to the end. If we happen to have a pandas data frame, and that pandas data frame includes some macroeconomic data, there's a lot of different ways that we could model the names of those columns. Here, we have some clear grouping and some clear relationship between these columns. We have GDP for two different regions. We have population for two different regions. Presumably, this is some kind of time series data. And we can model these column names as strings, which seems to be the case of how pretty much everybody always does this. Or we can model these as tuples. And when we dig at that a little bit more, we can see, well, if we model these as tuples, then we can do some very useful things, like we can index slice into this to just get the populations or just get the GDPs. And prior to recent version of pandas, we could even, for example, do a group by on the columns in order to perform some sort of manipulation on these like values. Well, if we dig at that a little bit, we'll see at its simplest case, these two pieces of code, S equals ABC, D, E, F, X, Y, Z, and X's equals ABC, D, E, F, X, Y, Z, are encoding exactly the same information. Three entities. They're encoding that information in different ways. The differences between the two of these go deeper than one being a string and one being a list. In that, there could be a potential ambiguity. Is the next element, DEF, comma, XYZ, one element, or two elements, DEF and XYZ? And in the first case, it's potentially ambiguous. In the latter case, it is not. This leads us almost immediately to the idea of in-band encodings and out-of-band encodings. When we talk about in-band encodings, we talk about having one channel with multiple uses, Out-of-band encodings having multiple channels with their own distinct uses. And here we can see a clear example of this. In the string formulation, we have one channel, the string data, that's encoding multiple things, the entities and the delimiters. In the list formulation, we've used a programming language mechanism to separate the encoding of where the elements begin and end from what the elements are. The first formulation is fundamentally ambiguous and requires some disambiguation technique. The latter formulation is fundamentally unambiguous. In fact, if we look at how disambiguation of in-band encodings actually plays out in practice, we can see that largely there's only about 3 techniques that people ever use: partitioning, prefixing or structuring, quoting or escaping. Where quoting and escaping, we've all seen this before. In CSV, you put quotes here, except the quoting or escaping has a certain dissatisfactory nature to it, because what if the entity has a quote in it? I oftentimes need both quoting and escaping together. One alone is not sufficient. With prefixing, this doesn't actually come up that much in a lot of the code that we write. We'll see prefixing as an approach in, for example, how Git stores underlying objects, or how we might write network protocols. A very simple way to create a packet-based network protocol is you emit the length, you tell somebody what's coming next, and then you give the entity. And so the reader can say the next 10 bytes are the payload, and everything following that is the next message. There's some limits to what you can do with prefixing. You could think of this as a structuring mechanism. You could first tell them this is what the packet format looks like, but in practice, this doesn't actually come up as frequently. Partitioning, however, comes up all the time, and it comes up in many different auspices. One of the interesting things about creating a unifying theory is it manifests itself in places you wouldn't even expect that on surface don't look anything like each other. For example, float nan is a partitioning. Here, we have some data, and we're representing there's some missing data. So what we do, if this is floating point data, is we say, IEEE 754 double precision floating point values have specific bit patterns that indicate NAN. They even have payload lands. There's more than one of them. And if we happen to have that one specific bit pattern, it is unambiguously never a value. It is always a NAN. But if our underlying data is integer data, there is no one singular specific bit pattern for integers that cannot potentially be confused for a value. Obviously, if our values are always positive, then a negative value could indicate this. We have some implicit partitioning. But in many use cases, 0, does that mean missing data, or does that mean the data was there but it happened to be 0? And in those cases, there's no choice but to use an out-of-band encoding. That's what a NumPy masked array is. That's what dtype capital I in 64 in pandas is all about. But it goes beyond just that, because when you're writing command line scripts and you happen to have files on your file systems with spaces or colons in their name, what do? Well, you pass that -print0 flag to find, and then you notice that almost everything in core utils and more utils takes some flag, either a -0 or a -z or something like that, to indicate that its input is null byte separated values. Here, xargs takes a -0 flag. Because on all file systems that are currently in use, there are generally 2 characters that cannot appear in a file name, one of which is a null byte. Thus, we've partitioned the space of all the valid characters that can appear in a file name in order to be able to unambiguously indicate whether this one given byte is part of the file name or the delimiter. And you can see mistakes that are made. For example, when you set your path in a shell script, you colon separate it. What happens if the path has a colon in it? There is no way to resolve this. You cannot have a system path in a shell script that has a colon in it, because there's no way to quote that, there's no way to prefix that, there's no way to disambiguate that. If you happen to be using Z shell, you actually can use a different out-of-band encoding for what the system path is that is translated but not propagated through sub-processes in order to unambiguously indicate that this is one part of the path that perhaps happens to have some colons in it. Note, some of these mistakes were made many, many years ago, back when computers were very simple devices where keyboards did not have lowercase letters. Perhaps computing has evolved since then, except when we look at very modern tools that were created in the recent past, we see these mistakes are still being made. If you have a Docker container and you want to mount a volume on it, you mount that volume by specifying the source, colon, the destination. What if the source path has a colon in its name? This is an obvious error that somebody made in designing this tool because they didn't have a foundational theoretical framework to guide them. If we look at, I would say, better design tools like BRAP, you can see BRAP disambiguates this. out of band by passing the source path and the destination path as two separate arguments. And I know some of you have said, hold on a second, spaces in file names, colons in file names? No, I forbid it. But this is going to get me even more agitated. File names are for human beings. Human beings like spaces, they like colons. I have folders on my computer called Star Trek, Deep Space Nine, Stargate, SG-1, that contain completely legal downloads of these television shows, and I would like to be able to share them on my completely legal Plex server by mounting these into my Docker container. It's often the case that once you discover this theoretical framework, you wonder, why didn't I realize this before? Once you see it, you can't unsee it. And you realize obvious mistakes that you've been making all along. They're staring you in the face. There's one tool that I think is a fantastic tool, but clearly the developers of this tool have fallen into it's exactly the same mistake, and you'll see it almost immediately. Xarray is a tool for coordinated dimensioned n-dimensional data. It's basically NumPy with the idea of pandas indices. And with Xarray, we can specify what the dimensions are, and we can select values by saying select x equals, select x and y equals, and select out aspects or positions or values, scalar values from our data. We can even do interpolations of this data. We can say select for these particular x points, and if they are not present, linearly interpolate or use any interpolation methodology that's provided in SciPy by passing a keyword argument method. We pass a keyword argument with the dimension and a keyword argument with the method. What happens if our dimension is called method? We have an in-band encoding ambiguity. This is a design mistake. It's staring you right in the face. They made a mistake. They had one channel, the keyword arguments they passed in. They were doing two things in it, saying this is the dimension I want to use, and the modality of how I want to use that dimension, and there's a conflict that cannot be resolved. You cannot have this in Xarray. And so, if the Xarray core authors in their documentation say, by the way, you can't have a dimension called method, I think we're too far gone if that's the advice that we give. Honestly, this is a mistake. And the resolution for this mistake is quite straightforward. Well, this is a bounded modality. So we could just, for example, use some part of the descriptor protocol in order to extract that. We can break this into two parts. We can identify the interpolation method and return some kind of descriptor object, and then we can access the elements that we want. Now, the genesis of this was asking about PEP 570. And for PEP 570, the specification of positional-only arguments, we were curious this should not exist in the first place. We'll just accept that somebody wrote this code. Here, if we happen to have a function of x and y, we can call f 3 times and pass in keyword arguments x and y. And I'm sure you can all see it. If we happen to have a function of n, there's an ambiguity. Does that n mean the n number of times or the n argument that I'm passing to the underlying function? And with PEP 570, positional-only arguments, we can actually disambiguate this. Here, we can see this is a partitioning. We partition the space of all the arguments into those that can only ever be the ones controlling this functional programming construct and the ones that are actually passed to this entity. And so we can see a direct, applicable, perhaps narrow or niche reason for why this might exist. And I tell you I lied because I will tell you why it is that this shouldn't exist. First, this should not have a return value, it should have a yield. And now that we have a yield, we shouldn't have an ending modality, it should just be a while true. And if that's the case, this should just be a list comprehension. This didn't need to exist in the first place. But if it did exist, I can tell you why the way that it was formulated originally might need positional-only arguments. It turns out that once we start going, the theory reveals itself to us and answers many questions that we might have batted about for years. For example, we're talking about functions. Why even write a function in the first place? Assume that we have some script that somebody's written that does some data loading. It loads data, it cleans data, it processes that data, and it generates some report. And one of our colleagues writes a script, and it turns out that script looks identical to ours. Somebody might ask, well, should we turn this into a library? Should we unify these? Should we have one function that does both of these? But before we look at that, we might consider that it's unlikely that we'd have exactly the same code arise in both places. More likely, I might read from some source data and you might read from some other source data. Very likely, I might do one slight thing differently than you, for example, remove outliers. And when we look at the existing frameworks that we have for determining, should we turn this into a library function, take all of this repeated code and make it a library code so that we don't have this repetition, what are we told? Don't repeat yourself, DRY. Here, we do have an attempt at creating a theoretical framework, but it's absent of any rigor. Here, I think things like DRY are very much like that one uncle we all have, whose underlying thesis, epistemological basis is, if it rhymes, it must be true. No, just because something rhymes doesn't mean it's true. Just because you can come up with an acronym or initialism for it doesn't mean it's true. And I'll prove it to you. DRI could also stand for do repeat yourself. If you can play it both ways, it's probably not true. If the theoretical framework we're coming up with is actually true, if it actually has some substance, then it allows us to predict things, it allows us to extrapolate, it allows us to distinguish two things that might look the same, or take two things that look the same and identify that they're actually much more similar than we thought. In other words, if it's true, we can make predictions, extrapolations, and distinctions. I guess if I reorder that, I could say extrapolations, predictions, and distinctions. You know, the more it rhymes, the more I'm convinced. But I want to show you what it means to predict, extrapolate, and distinguish. When we talk about don't repeat yourself, oftentimes we find that this guidance is not altogether very meaningful because it's not don't repeat yourself, it's don't repeat yourself except in the cases where you do repeat yourself. I don't know what to do. And I find this very similar to moralizing advice or pat advice that you get when somebody says, for example, look both ways before you cross the street. Except I don't. I'm an adult and I make choices. For example, when I'm out far away from any civilization and I can see 10 miles down on each side of the road and I can hear a car coming from 20 miles away, I do not look both ways before I cross the street. There are qualifications that indicate why I perform this behavior. Also, there are cases where I make that choice incorrectly. For example, when I'm in Bengaluru and I don't look both ways before I cross the street, perhaps I quickly realize that that was a bad decision. Well, oftentimes the construction of this theoretical framework can be something that we can very methodically engage in by finding the distinctions. In other words, by finding the boundaries of the problem, mapping out the two sides of the spectrum, and seeing where they begin to overlap. And through that, we can discover what is this truth. Why is it that we do it one way? Why is it that we do it the other way? And what does that tell us? If we return to our writing a function example, we could imagine that we write a function like this. Do report. And we eliminate all the repetition here. We did not repeat ourselves. Except we can very easily think about what will happen next. There were two users here who wrote two pieces of code. Likely, they had two different stakeholders. And those two stakeholders maybe don't care that much about how the code was written. They care about what the code does. So one of the stakeholders says, you know, can you customize the number format for me? And also, actually don't want outliers. And as these two pieces of code begin to diverge, for example, one of the other users says, oh, you know what? My data format changed slightly overnight. This was a feed of government data I was looking at, and they made some slight changes to it. I need to do some pre-processing. These two call sites begin to diverge. In fact, they may even diverge in arbitrary ways, where perhaps we even have to pass in some lambda to do the pre-processing. As these diverge, we can imagine that the keyword arguments on that singular library function will also begin to profligate. And this is going to become harder to read. We're going to see this geometrical increase in complexity of this. It's going to be harder to test, harder to understand, harder to document. And we're going to see that we're going to very quickly regret having unified these into one function. In fact, we can identify where the hotspots for that divergence will occur because it's very likely that divergence will occur on input or output to the computational routine. It is very commonly the case that end users say, I want to look at it slightly differently. Can you customize that for me? And suddenly the beautiful framework that you've written requires keyword arguments being passed all the way up and all the way down. Or if you're working on other people's data, they don't ask you before they change the way the data is formulated. And by the way, we can't have any downtime. You have to fix it right now. And so preserving some flexibility on those output and input sites is going to allow us to avoid the consequences of premature unification of these. It's often the case when we talk about input and output, they're often ad hoc modalities, things that we need to do right then and there, only specifically for one side of the problem. And in fact, if we had left this as two distinct blocks of code, and a user came in and asked us to make changes, we could have just made those changes superficially in the scripts themselves without ever having to encounter the problem of prematurely unifying them. In fact, if we think about it, the premature unification that exists in that generate report probably was a bad idea. Probably we should have eliminated the generate report function altogether and given somebody a little bit more flexibility in how they produce this output data, because we can anticipate almost immediately. The moment you put something in front of somebody, they say, it looks good, but, and then they ask you to change some small, perhaps even inconsequential detail of the output. When we think about writing functions, we can clearly see what we're talking about is something that we visited before. The theory that we find here is not always novel. This is just a theory drawn from database technologies, the idea of eliminating update anomalies. In other words, when we look at the repetition that we're trying to eliminate, there's actually two types of repetition here. There's coincidental repetition and intentional repetition. Where coincidental repetition is, they just happen to look the same, but they might readily diverge over time as requirements change. Versus intentional repetition, they look the same because they always are the same. They must be the same. These are just two sites of the exact same thing. Well, clearly, if we have coincidental repetition, we want to avoid unification. We want to avoid writing a function as long as possible because we are going to be burnt by writing a function. Whereas if we have intentional repetition, we absolutely definitely want to write functions. Otherwise, we open ourselves up to update anomalies. There is very clear guidance for when we do or don't write a function. There is, of course, some fuzziness. This is not a concrete, quantified theory. But we have something a little bit better than, well, I guess it depends. Notice that we can actually still produce precise advice, which maybe means that we're on the right track, and it tells us something that we didn't already know. It tells us something that is operationalizable, something that we can use to actually make a decision then and there without having to try it both ways, without having to go back to the drawing board and say, well, you know, you said do this except in those circumstances, but I don't even know if I'm in those circumstances at all. I think this is what's missing when we try to find, when we fail to find the meaning of our work, when we fail to find these theoretical frameworks and we rely on these pat answers. And so going back to my relative, who probably does not deserve to be called out in front of all of you, despite the complete idiocy of the thing that they said, perhaps if they were following the same track, they might have instead taken a moment and answered, did you know that some oranges are specifically cultivated for producing juice? I bet you didn't know that because you're asking me this question in the first place. Can I share with you an interesting detail about oranges? They have these things called juice vesicles, and sometimes they're larger and sometimes they're smaller. In fact, if you think about it, when you're creating orange juice, there's many different ways to create orange juice. You can squeeze it, you can ream it, or you can blend it. And I bet because you live in New York City, when you've had fresh squeezed orange juice before, it's been blended because it's a very fast way to make orange juice, and because it's blended, it's more cost efficient for the person making the orange juice. They take the entire orange and they get exactly that weight in orange juice. Whereas when they blend or ream it, they get a minimal amount of the juice out from the underlying weight of the oranges. But when they blend oranges, they blend the pith in. And when they blend that pith in, it gets bitter. And this is why you're telling me today, in the nth year of your life, that you like fresh squeezed orange juice. You probably have never really tried properly fresh squeezed oranges. I can make a prediction, and I bet it's correct, and I can validate my theoretical framework through that prediction. This kind of search for meaning, I think, is critical in our work. The development of a foundational theoretical framework for being able to answer real questions is the only way in which programming as a discipline could ever become an engineering. And I'll be honest with you. This seems like a lot of effort. You may ask yourself, is it really worth it? And I have to think for a moment, is it worth it or not? Well, I'll say, is it worth it for me to come to PyCon India 2024 and present this in front of all of you? Absolutely. I want to thank all of the organizers for putting on such an amazing event. This has been a fantastic opportunity for me, and I hope for you as well. I have loved every minute of my time here. I've loved every minute of talking to all of you. Thank you so much for this. But that's not the question. The question is it really worth all of this effort? Because ultimately, as we've also seen from many of these talks, this theoretical framework, what does it really add to my life? I could just do some generative AI nonsense and make lots of money, and it doesn't even have to work or deliver any real value. What's the point? Well, when you ask me, is it really worth it? I'll have to think for a little bit, but I can tell you very confidently, I guess it's a series of trade-offs. It really depends on what you're trying to do. Thank you very much.